Hello guys, my name is Lazaro, and today we're going over a medium LeetCode question. The question is called Asteroid Collision, and it says we are given an array, asteroids, of integers representing asteroids in a row. For each asteroid, the absolute value represents its size, and the sign represents its direction. Positive meaning right, negative meaning left. If each asteroid moves at the same speed, each asteroid moves at the same speed. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If both are the same size, both will explode. Two asteroids moving in the same direction will never meet. So right here in the problem, as you can see, we have 5, 10, and then -5. So the -5, since it's negative, that means it's an asteroid of size 5 moving left. And then this asteroid of size 10, since it's positive, it's moving to the right. So since one is moving to the right, this 10, and then the other one's moving to the left, they will collide. And since the 10 is larger than -5, the -5 would explode and the 10 remains. So that's why the output is 5 and then 10. Right here, as you see, there's one that's positive and then the other. So one is going right, one's going left. They will meet and they will collide. But since they're both the same size, they both explode and we output nothing. Same thing right here. This is pretty similar to the first one, but since the -5 is larger than the 2, it explodes the 2 and it continues going down. And then once it meets the 10, since the 10 is larger than -5, the -5 explodes. And then right here, as you see, none of them are meeting. There's 2 going to the left and then 2 going to the right. So nothing will ever happen and we just return the same array. All right, so let's see how we can solve this problem. So one thing I first want to make clear is, as we saw there in the third example, is we could have an array that's 5, 10, 7, 6, 3, and then -20. But since this -20 is larger than the 3 will come out. And it's still larger than the 6, larger than the 7, larger than the 10, and then larger than the 5. So one thing that we already see is that while we have a bigger one, we want to try to break down until we find a value that's larger than this 20, until we find an asteroid that has a bigger size. Now another thing is, let's consider all the possibilities that they might crash into each other or two asteroids might collide. So let's say we have an asteroid that's positive, so it's going to the right. And then let's say the second asteroid is positive. Would these two asteroids ever collide? It won't. Let me just give them a value so you guys can understand. Okay, they would never collide. Now let's continue with a positive, but then let's say the other one, the second asteroid, is negative. Here they will collide. So that's already one possibility. Let's see if there's any other. Now let's say the 5 is negative. And then the 7 is positive. They're going away from each other, so they would never collide. Now let's stick with the -5. Now let's make the 7 negative. They're both going in the same direction, so they would never collide. So as you see right here, there's only one possibility where two asteroids will collide. So this is the only one we want to look for, or we want to check for while we're adding to our array, which will be the output array. So what have we learned so far? So from up here, when we talked about this example where the 3 got knocked out, the 6, the 7, the 10, and the 5. We already know with this, we're going to be using a while loop because we want to be checking if the last asteroid is smaller or less than or equal to the current one. Something else that we know is Since we want to keep track of these asteroids that we've seen and that haven't collided or that have collided, we know we want to keep track of this in an array. But we're be taken away from the end of that array and then comparing it with the new asteroid we want to add or compare to. This tells us that we're going to be using a stack. So from here, we first add 5, then we add the 10 and the 7. So it's 5, 10, 7, I believe that's a 6, and then 3. And then we add the negative 20. But the size of this asteroid, and which is 20, it's larger than 3. So we pop the 3, and then compare it to the 6. We pop the 6, and then we continue until we get all the way to the end where we can no longer pop, and we realize that that asteroid is the largest. So we know that. We know we'll be using a stack and a while loop. We also know what condition to check for. We know that the only one we want to check for is that the current asteroid we're looking at, if that current asteroid is negative, so current, if that current asteroid is negative and the last asteroid is positive, it's greater than or equal to 0, because there we go. If it's greater than or equal to 0, we know that there will be a collision, because that's the only possibility. From there, once we know it's a collision, we just have to check which one would explode, or will they both explode. From this, we also know that we need exactly 2 asteroids to check for this collision. So let's write down everything we know. So we're going to be needing a stack. To keep track of asteroids. We're going to need a while loop to check how many asteroids we can collide with and explode. How many asteroids can explode. We also know that we know there's a condition only if one of them is positive and the current one is negative. So there's only a collision when the last one is less than 0 and the current one it's greater than or equal to 0. And of course, we need 2 asteroids for collision. So in our program, in our code, we want to solve these 10 bullet points or check them off. All right, now that we know this, let's actually start writing the code out. So since we know we're going to need a stack, let's keep track of that. Let's create a variable, let's call it stack. Make that an array. And now let's start to iterate over our given input. So for I in asteroids, the length. So now this is the current index we're looking at. Let's create current. Actually, let's call it asteroid is equal to asteroids at that index. So this is the current asteroid we're looking at. Let's add this to our stack. So let's append it to our stack. Perfect. Now, since where are we using the stack? We already know that. So we can cut off this one. This one's done. Let's just put a check mark right here. Now we need a while loop to check how many asteroids can explode. But before we do that, keep in mind this is not ordered, but before we can do this while loop, we know that we need 2 asteroids. 2. So let's have this condition set inside of the while loop. Now, we can do while the length of asteroids, while it's greater than or equal to 2, we can start our work. Perfect. So now that means we got rid of this while loop. We already did that. We implemented it. And we're already checking that we have at least 2. Now what we need to do is this collision. Check for it. Check if there's a collision or if there's not. So inside this while loop, we're going to want to get our 2 asteroids. So let's just pop it from our stack. We already appended it. So the first one we pop is going to be the current one. It's going to be equal to asteroid right here. The reason we want to append it is because just in case this doesn't go through. Just in case we only seen 1 asteroid, this while loop will not run. So that's why we need to append outside of the while loop. Perfect. So let's create a cur, which stands for current, and that's going to be equal to our current asteroid, which we can get by just popping the stack. And then the last asteroid, so the asteroid before current, since we already popped it once, we just need to pop the stack again, and we will get last. Perfect. So we have our 2 asteroids. Now it's time to do the comparison. If last is greater than or equal to 0, so if last is positive, and cur, or current asteroid, if this is negative, we know they will collide. So if they collide, let's actually go back to the problem. If they collide, now we want to do this part. If 2 asteroids meet, the smaller one will explode. If both are the same size, both will explode. So let's do that. Inside this if block, let's create another if. So if the absolute value, because remember, the negative and positive sign just determines its direction. So if the absolute value of current, if it's greater than last, then this means that our current asteroid is larger than the last one. So the last asteroid is going to explode. And by exploding, we can basically say that let's not add it back to the stack. Let's just add current. Perfect. So from right here, we're taking care of our current asteroid if it's larger than our previous asteroid. But what if it's the other way around? If it's the other way around, we can do an else if absolute value of current is less than last, that means this current asteroid we're looking at is smaller than the previous one, meaning this current one would explode. So since it exploded, let's not add it back to the stack. let's just add the one that didn't explode. Oh, not current, sorry, I mean last. Perfect. Now in this else means that they're both the same size. They're both equal to the same value. And here we don't want to add any back to the stack because they both exploded. So basically we don't have to write an else. We can just ignore it. Because the three conditions were the current asteroid is larger than the last, or the current asteroid is less than the last, or the current asteroid is equal to last, it's all taken care of. Now this is if there is a collision. If there isn't, we create an else, and if there isn't a collision, we just append the last and current. So append the two asteroids we were looking at. Now the order is important. The one that should be appended first is last, because that was the previous one. But then the other one that should be appended, the one that should be appended second is current. And then of course, since there is no collision, we want to get out of this while loop, because what this while loop is doing is checking if there is any more collisions after last. But if there isn't a collision, we just break. And then outside of this while loop, all we do is we return our stack. And that's the whole code. This right here. So if you guys want, let's actually try to visualize this a little bit. Say down here we're gonna have our stack. And then let's say our asteroids, say asteroids was, you know what, let me move this forward. Move it like that. And I'll write asteroids up here. Let's make this equal to that example. 5, 10, negative 5. All right, so let's run this through. For I in asteroids at length, it will get this I, which is 0, this index. Now, the value at index 0 is 5. So we add it to our stack with this line right here. Now in our stack we have 5. While asteroids dot length, oh, actually that's a mistake I made. It's not asteroids, it's stack. There we go. While stack dot length is greater than or equal to 2, we want to run this while loop. But in this case it's not, we only have 5. So we continue. Now our index is 1 and the value at 1 is 10. Then of course we append to the stack with that line right there. And our stack becomes from 5, changes to 10. Now while stack.length is greater than or equal to 2, is this the case? It is. Because right now we have 2 elements inside of stack. So this while loop runs and it pops current. Current is equal to 10. And then last is equal to 5. If last is greater than or equal to 0, okay, that checks through. And current is less than 0. This does not check through. That's false because current is greater than 0. So this if block, it doesn't run and we get sent to else. Else just appends our last and current in this exact same order, and then we continue. Now finally we're at index 2. The element at index 2 is negative 5. We add it to the stack, and now we hit this while loop because this length is greater than or equal to 2. we pop current and we pop last. So let me actually pop it. I know I didn't do it before, but I'll pop it now. Now, current is equal to -5, and then last is equal to 10. If last is greater than or equal to 0, that checks through. And current is less than 0. This is -5, so that goes through. Perfect. Now we're going to do one of these, if or else if. If the absolute value of current, aka 5, if that's greater than last, we're going to want to run this. But this is false. Since that's false, we go to this else if. If the absolute value of current, which is 5, if it's less than last, we want to do this, and since this is true, rerun it. Now we do stack append last. Last is 10, so we append 10. Oops. Now this while loop, runs one more time. This time when it runs, it's going to pop 10 and 5. So current will be equal to 10 and last will be equal to 5. These two are positive, so we're going to be hitting this else block right here. And it's going to append them. It's going to append last, which is 5. And then it's going to append 10. And then it's going to break out of the while loop. And since we're at index 2, we no longer we've reached the end of the length of the asteroids. So we're done with this for loop. And now we return stack, which is 5, 10, and that's the right answer. So, all right, we know how that works. We're glad that works, of course. But now let's actually write out the code. Let me shrink this. Okay. And then let me move this right over here. There we go. So that's the code we wrote. And now let's see if it actually works. So this declares a variable called stack. And now let's go over that asteroids array. Perfect. Now let's get our current asteroid. And let's add it to the stack. Now we want to do our while loop, while the length of the stack, while this is greater than or equal to 2. Let's get those two asteroids that we want to compare. And now let's see if they will explode. They will only collide and explode. They will only collide if last is greater than or equal to 0 and current is less than 0. Now, here's where we see which one explodes. The absolute value of current is less than last, then the one that explodes is last. And the one that stays is current, so we just append it to our stack. Else, if the absolute value of current is less than, there you go. If it's less than last, then the one we want to append to our stack is last, because that one was greater and it did not explode. Else, if our two asteroids, if they don't collide, then we just want to add them back to the stack in the right order, of course. So first last, then current, and then we break out of this while loop. Then after that, all we want to do is just return stack. So let's run this code. That works. Let's submit it. Perfect, and it runs. All right, if you guys enjoyed this video, then make sure to check out our Discord channel, which is linked down below. We send out advanced and beginner problems every single day. And we also do videos for people to understand how to solve them, just like this one. Alright, other than that, I hope you guys enjoyed, and thank you for watching.